Good afternoon to all, and welcome to Anu Krishna online chemistry classes. And today we'll discuss about the chemical classification of matter. And already in the previous class, I explained the physical classification of matter, solids, liquids, and gases, and also the properties of solids, liquids, and gases. And today we'll discuss about the chemical classification. Okay. So, based on the chemical classification, the matter can be divided into again two types. One is a pure substance and other one is a impure substances. Based on the chemical classification, the matter can be divided into two types. One is a pure, another one is a impure substance. And second thing is a impure substance. Pure substance and impure substance. Again, what is the meaning of pure substance? Pure substance is nothing but pure substance is a substance. It is made up of only one kind of atoms. One kind of atoms. The compound is also consist of the only one kind of matter. Then it is called as a pure substance. For example, hydrogen element. The hydrogen element is made up of only one kind of hydrogen atoms. Then it is called as a pure substance. Or if you take the nitrogen is also made up of only one kind of atoms. Then it also comes under the example of pure substance. If you take it the water, pure water is nothing but there is no any salts, there is no any dissolved salts, there is no any dust particles, there is no any remaining impurities. Then pure water is a compound. Okay, so the compounds also examples of the pure substances without any impurities, without any other things. Only the compound is available purely. Then it is also compound called as a pure substances. Okay, the pure substance is made up of only one kind of atoms or one kind of components. Then they are called as a pure substances. Impure substances is nothing but they are made up of two or more pure substances. The impure substances is a substance. It is made up of two or more pure substances. Okay, now, for example, the soil. The soil is a combination of two or more pure substances. Salt water. The salt water is the combination of two pure substances. One is a salt, another one is a water. Next, urea in water. Urea is also one of the substance, pure substance, and then water also one of the substance. Air is a mixture of several pure substances. If only nitrogen is present, pure, but in air along with nitrogen, oxygen present, carbon dioxide present, certain amount of dust particles also present, then it is also impure substances. Okay, now like that we are explaining. And again, the pure substances are divided into two types. One is a element, another one is a compound. Okay, the pure substances can be divided into two types. The pure substances can be divided into two types. One is a element and the second thing is a compound. And the second thing is a compound. One is a element and other one is a compound. So these two are comes under the examples of the pure substances. Then what about the definition of the element and what are the different type of elements are there? Then what is the classification of elements? Here the element can be defined. The element is a pure substances which cannot be divided into further simple substances. An element is example of the pure substance which cannot further divide into simple species by using any physical methods or chemical methods. Okay, then the pure substance is called as a element. Okay, what are the different type of example elements are there? hydrogen, helium, lithium, beryllium, boron, oxygen, nitrogen, calcium, titanium. These all are the different type of elements. Total nowadays 118 elements are available in the periodic table. 118. Okay. So that is about the thing. Later on, the element definition also again changed. The element is a pure substance. It is made up of only one kind of atoms, or it is also takes part in the chemical reaction. It is also takes part in the reaction. Okay. The first definition is the element is a pure substances which cannot be divided into simple spaces by using any physical methods or chemical methods. Later on, the definition was shifted. Okay. So element is a pure substances. It is made up of only one kind of atoms. What are the examples? Hydrogen, lithium, beryllium, etc. Okay. Next, the classification of elements. The elements are broadly classified into majorly in three types: metals, non-metals, metalloids. Elements are classified into broadly three types: metals, non-metals, and metalloids. Then the given element is called as a metal based on the some physical properties we are explaining. For example, the element which can possess the high melting point and boiling point, or the elements are available in the solid state, or the elements are exhibit the malleability property. Malleability is nothing but making into thin sheets. Okay, now aluminum sheets, copper sheets, or iron sheets like that. And ductility. Ductility is nothing but making into whites, copper whites, okay, now gold whites like that. Conduction of heat and electricity. Any particular element which can allow the electric current through them and they can act as a conductors. Then the respective element also example of the metal. Next, lustrous property. Reflection of sunlight. Reflection of sunlight are the element which is having the bright surface or shiny surface. Next, sonorous. Sonorous is nothing but any element or any substance dropped on the hot surface which can give the sound or making a noise. Okay. Then the property is called as a sonorous. So based on these properties, we will explaining the given element is example of the metal or not. One is the solid state of the element, melting point and boiling point. Most of the metals are available in the solid state except mercury. Melting point and boiling points of metals are very high. They are exhibiting the malleability, they are exhibiting the ductility. Okay. Next one is the conduction of heat and electricity, sonorous property, making sound, lustrous property. Okay. Next, any element cannot obey these conditions, then it is called as a non-metal. That means cannot exhibit the lustrous property, cannot exhibit the sonorous property, malleability, ductility, conduction of heat. Here also few exception conditions are there. Even though non-metals, they are exhibiting the lustrous property. Iodine. Iodine is a non-metal, it can exhibit the lustrous property. Okay. Next, graphite. Graphite is a non-metal which can conduct the electricity. And graphite, diamond is a non-metal which possesses the high melting point and boiling point. Like that, few exceptional conditions are available. Okay. Now, so that is about the non-metals. So the elements are classified into metals, non-metals, and metalloids. And again, what is meant by metalloids? The few elements are exhibit the both metallic properties and non-metallic properties. Then they are called as a metalloids. What are the examples of metalloids? Arsenic, germanium, okay, no, antimony. These are the some of the examples of metalloids. So like that we will explain the elements are classified into three categories: metals, non-metals, and metalloids. Okay. Next, after that, compound. How to define the compound? A compound is a pure substance which can decompose into simple species. A compound is a pure substance which can be divided into simple spaces by using the physical methods or chemical methods. Then the respective substance is called as a compound. Or one more way, a compound is a combination of two or more elements. They are present in the definite proportion by mass, fixed proportion by weight. Okay. A compound is a pure substance which can divide it into two or more simple species. Okay, now by using any physical methods or chemical methods. And also, what are the elements are present in the compound? They are present in the fixed ratio by weight. If you take it the water can be divided into two simple pieces, H2 and O2, hydrogen and oxygen, by sending the electrical energy. It is a chemical change. Okay, now by using the some suitable chemical techniques, the compound can be decomposed. Okay, now, and in this compound, the elements are present in the fixed ratio by weight. Here, how much amount of hydrogen is present? 2 grams. Atomic weight of hydrogen is 1. Like that, 2 hydrogens are present. 2 into 1, 2. And each oxygen atomic weight is 16. Okay, now. So 2 is to 16. Then 1 is to 8. 1 is to 8 ratio by weight of hydrogen and oxygen present in the water. And while taking the carbon dioxide, carbon atomic weight 12 and 2 oxygens are 32. 12 is to 32. Then if you take the ratio, 4 3 is a 4 8 is a 3 is to 8 ratio by weight of carbon and oxygen present in the carbon dioxide. Okay. Next, if you take the carbon monoxide, then what about the ratio of elements? 12 is to 16. 4 3 is a 4 4 ja. The formation of the carbon monoxide compound, the carbon and oxygen ratio is 3 is to 4. Okay. So the compound is a combination of two or more elements. They are present in a fixed ratio by weight. Then the respective substance is called as a compound. Okay. By using the physical techniques, the respective elements are not separated from the compound. From water onwards, we cannot separate the hydrogen and oxygen by using the physical changes. Only with the help of the chemical changes, we can separate the two different elements are present in a compound. While the formation of the compound, maybe absorption of energy takes place or maybe releasing of energy takes place. Okay, maybe exothermic reactions or maybe endothermic reactions. With absorption of energy, okay, the reaction takes place, then it is called as a endothermic. With releasing of energy, the reaction takes place, then it is called as a exothermic reaction. Like that we are explaining. Okay, now. Then the properties of initial elements lost after the formation of compound. For example, two molecules of hydrogen react with one molecule of oxygen. It converted into two molecules of water. The properties of hydrogen different. The properties of oxygen also different. Hydrogen is combustible substance. Oxygen is support the combustion process. Okay, now. But the water is not support the combustion. It is put off the combustion process. Okay. Hydrogen is a gas. It cannot support the breathing process. Oxygen also gas. It can support the respiration process. And water is a substance or compound, and it can be used to the drinking purpose, agriculture purpose, and various uses. What are the properties exhibited by the initial substances? The properties are completely lost after the reaction. Then the properties of the final substances, the properties of the initial substances, both are entirely different. So that can be happened in the formation of compound. And energy absorption and energy releasing. These all the different type of things happened in the compound. Okay. Next, after that, compounds are again divided into two types. One is organic compound and other one is inorganic compounds. Organic compounds are nothing but the compounds which are obtained from the living things. The compounds which are obtained from the living things, then they are called as organic compounds. Okay. Organic compound is nothing but from living the things. Example, citric acid, citrus fruit. Okay. Malic acid, apple, like that. Next, if you take the ascorbic acid, lemon, and formic acid, formica, red color ant, Like that we will take it. Okay. And inorganic compounds are nothing but the compounds which are obtained from the non-living things, either rocks or minerals. Either rocks or minerals. Then they are called as inorganic compounds. What are the examples of inorganic compounds? Either hydrochloric acid, either carbon dioxide, either NaOH, either sulfuric acid. These are the different type of examples of the inorganic compounds. Organic compounds are examples formic acid, acetic acid, okay now, and malic acid, ascorbic acid, like that is all the things. And in organic compounds, the carbon is essential element. In organic compounds, the carbon is an essential element. While taking inorganic compounds, except the carbon, the remaining all elements are discussed in the inorganic compounds. Okay now? Except the carbon, remaining 117 elements, their formation of compounds and properties, either physical properties and chemical properties, all these things are discussed in the inorganic compounds. Okay. Next, after that, impure substances. Impure substances, best example, mixtures. Mixtures are examples of impure substances. Mixtures are examples of impure substances. Okay. Then what is meant by mixture? Okay. Mixture is nothing but the combination of two or more pure substances. Mixture is a substance. The combination of two or more pure substances. They can be present in the variable composition or they are present in the any ratio. They are present in any ratio and they can be separated by using the physical methods or chemical methods. Then the respective new substance is called as a mixture. Mixture is nothing but it is a combination of two or more pure substances. The two or more pure substances are present in any ratio and the two pure substances can be separated by the either physical methods or chemical methods. Then the substance is called as a mixtures. Salt in water. Salt is a pure substance. Water is also pure substances. The combination of salt and water we are getting the impure substance. Example seawater. The seawater containing the dissolved salt, NaCl in water. We can separate the salt from salt and water by using the evaporation technique. And sugar and water also we are separated by using the evaporation technique. The sand and iron fillings are separated by magnetic separation. Okay. Sand is a pure substance and then iron fillings also pure substances. When both are present, we are getting the impure substance, then it is a mixture. Then what are the pure substances are available? Sand particles, iron fillings, both are separated by using the magnetic separation technique. The sand in water, the sand is a pure substance, water also pure substances, both are separated by using the filtration technique. Okay, so the separation of the pure substances is also possible and they are present in any ratio and the combination of pure substances. Then the respective substance is called as a mixture. And the mixtures are of again two types. One is a homogeneous mixture and other one is a heterogeneous mixture. Okay. How can you say that the given mixture is a homogeneous or heterogeneous? Already explained this example and I will take the vessel 100 ml of water and then sugar is dissolved in water. Whenever the sugar is added to the water, the sugar is completely soluble in the water and then the sugar particles are spreading throughout the mixture. The uniform distribution of sugar particles in the mixture, then it is called as a homogeneous mixture. Not only sugar particles, the uniform distribution of the components or the substance in the respective medium is called as a homogeneous mixture. The salt is added to the water. Okay, now after the salt completely soluble in the water, when you sip the water at the surface of the water, at the bottom or at the bottom of the layer or middle of the layer, the total water has which taste? Salty taste. When the sugar is added, the total water is getting which taste? Sweet in taste. Okay, now the composition of the substance uniformly distributed throughout the mixture, then it is called as a homogeneous mixture. Okay, air is also example of the homogeneous mixture. Next, if you take the one more thing, sand is added, or chalk piece is added, or iron fillings are added. Whenever the sand is added to the water, the sand is insoluble in the water and then just settle down at the bottom. Settle down at the bottom. The sand content is more at the bottom of the vessel, very less at the surface layer or middle layer of the water. Here, the substance is uniformly not distributed. Okay, the substances which are not uniformly distributed throughout the mixture, then the respective mixture is called as a heterogeneous mixture. Heterogeneous mixture. The composition of the substance not same throughout the mixture, then the respective mixture is called as a heterogeneous mixture. Sand in water, soil, chalk piece powder plus water, oil in water. Oil in water also example of the heterogeneous mixture. And classroom. The classroom also best example for heterogeneous mixture. If you take any property, either height of the students, either weight of the students, either talent wise, either grasping power wise, okay, all their properties are entirely different. That's why the classroom is also best example for heterogeneous. Okay, so these are the types of mixtures: homogeneous mixtures and heterogeneous mixtures. What are the different type of homogeneous mixtures and what are the different examples for heterogeneous mixture? Okay, thank you students. Subscribe my channel and share the video.